All right. I'm going to discuss about the technical writing in fluid mechanics lab uh, report. So that's what I'm going to discuss in this video. Okay. So here, this is a structure for formal report. So if you see here, there are so many things here. So this is like complete report writing. You have abstract, you have cover page, you have introduction, you have methodology, you have result, you have discussion, so many things. But for lab 1 and 2, we are just focused on title page. So you need to have a title page, okay? And then result and discussion. Um, you have conclusion, um, references, and then appendix. So these are the items which you need to include for lab 1 and 2, which are going to be individual. So that means everyone needs to submit this lab report. We'll discuss more about comprehensive lab report maybe in lab 4. That's where we are going to do group work based on um, comprehensive lab report. But for lab 1 and 2, these are the things which you'll be focusing on. So that's what I'm going to discuss. So we already talked about title page in the previous video, and I'll discuss about what needs to be included in result and discussion, and then what needs to be included in conclusion, and then references and appendix. Starting with results. So result is where you present the result of your experiment analysis. So when you have result, the first thing is to define any variables. For instance, if you are doing propagation of error calculation, maybe uncertainty associated with maybe density, then you need to write the formula for it. Okay, so it could be d density or mass, and then whatever you write the formula for it. So if you have any variables that includes the formula, it needs to be told to the audience what that variable is, and what is the definition of the formula, what is the definition of that variables, and what is the formula for that particular variable. So the first starting point would always to um, to understand what that variable is. And the next step is you have the data. Right now you have the data, and once you have the data, you need to present in some form. So it could be either in the form of figures or tables. These are the mostly used representation, and most of the time it is figure. And why figure? I think I talked this in the previous video as well. So in the result, you build your case, and so your results meet your experiment objective. So every results are always connected to the experimental objective. So we again, the first step is to define the variable, what it is, what is the formula for it. So that first step. Second step, you make the figure or tables based on the data you have. Okay, now once you have that, third step is, you make good figure, and you should know what the good figure looks like. Once you have that, then so this is the skeleton of the result. So when you have that, let's say this kind of plot, maybe something like this, then you can talk about the general observation. Remember, if you this is y variable, this is x variable, this doesn't speak to itself. Okay, this doesn't speak. You need to tell what information it has. So it's very important to explain about this plot, or it could be table as well, depending on what you have. Okay, so the general observation, you could see, you can say up to certain variable, the value increases and then it goes down. So that could be the general way. So you need to explain that. So always start with which figure you are describing. Maybe this is figure 2, the plot y versus x, and then second statement would be related with the general observation, what general observation you see, and it could be specific observation. Maybe at this point of x you have this maximum value of y, so that could be specific observation. You can also talk about, for this plot, best case scenario or representative case. At this point, whatever the value it is, if it is important to us that way, then you can also have a representative case as well. So these are the possible way by which we can discuss about the results. So again, to review, once you make your tables or plot, the first step is to talk about which table we are referring to. So table 2 or figure 2 shows the plot between y, q versus m dot. So that would be the first statement. Second statement is, again, it depends what information you want to show, but the general way is you can talk about the general observations, what happens to y as exchanges in general. You can also talk about a specific observation if you want to show at a specific location. Maybe we are interested in maximum point, or maybe we are interested in minimum point, so you can talk about that. And also you can talk about the extreme cases. So that's all about result. We are not discussing, we are just saying this is what important information I can get from the plot. Okay. So we are not doing the analysis, just the results that we are doing, and there are 3 ways by which you can do it. And if you are in figure 1, you're describing our figure 1, don't talk about figure 5, which is coming next. The figure can only be described once it appears. Okay, so if you are doing on figure 1 and then it is in page 1, and if figure 5 is in page 5, don't talk about figure 5. After page 5, you can talk about any figure previous, but it has to be there, only then you can describe. Okay, so that is important. So while describing what's going on figure 1, don't refer to figure 5. That's what I mean to say. So that's about results part. And usually result and discussion are together. This is what you need to do, right together. But here I'm only describing about the results part. What about the discussion part? Now there are 2 possibilities. One is you can write results separately, discussion separately, but in our lab we try to write together. So if you write it together, this is the skeleton for the discussion. You don't have to do this part, because this is kind of main results where we want to discuss. And if you write the result and discussion together, so the main result for that particular plot or table is already there, so you don't have to write it again. So next is, now this is where citation comes into picture. So you have certain results. Okay, now you list other researcher, what other people have done, similar to that experiment, what they have done, what they have found. So that's important. That's what discussion means. Discussion is more like compare and contrast. Okay, so maybe you find the coefficient of discharge to be 0.98 for that particular setup. What about similar experiment? What other people have found? And you must, maybe they found 0.90. Now you need to do compare and contrast of your result. If it is similar, why similar? What is the scientific logic behind that? If there is a differences little bit, then what is the differences? Maybe error associated with the instrumentation. You don't have, good measuring instrumentation, or some technical aspect. You need to discuss about all those things. So you need to compare and contrast, and you can get those information, when you do the citation is very important in discussion. Okay, you should have citation. And so whenever you are getting information from books, some other books or other research paper, you should always do the citation, extremely important. And write the reason, why you got close to that value, or if there is differences, you should write the reason for that. Okay, so so compare and contrast, very important. And as you try to compare and contrast your results, the wordings are very important. For instance, here the presence of secondary structure, so if you write suggests, and then it says demonstrate. So this is very strong. So negotiating strength of claim with the verb. So depending on how good your data is, you can change your wording, and the tense are also extremely important, like which tense, past tense, present tense, future tense. It's very important the way you use those tenses as well. And here you have maybe, will be. So the strength is increasing, your resolved strength is increasing. So the use of a specific word and tense is important as you try to write the discussion section. Usually it is written in the past tense. Okay, so when you try to um, compare your result or with the other researcher, or whatever the results you have got, they are usually written in past tense. um, Maybe you say figure uh, shows that q increased, so you may write increased with the increase in m dot. So I wrote in past tense, so usually the results are written in the past tense. So that's about the discussion. So basically discussion means, to summarize, you try to compare the results you got from your data to the other researcher or theory or any sources, could be book, could be paper, and see similarity and differences, and you must do the citation as you try to compare and contrast. Okay, so that's about discussion. And as I said, result and discussion sections are based on the questions that are provided in the lab manual for lab 1 and lab 2. So you should do based on that. Not only the plots, you could do the same thing for table as well. So table provides you the specific value of the variable, but again, if you just have the table and you don't discuss or what information there in the table, it doesn't compare. You are the one to make a comparison, right? So it's important to discuss about the information in the table or in the plot. Okay, so whenever you have this kind of table or plot, you should always do the discussion. You compare, for instance, here you can compare cylinder color by volume. So you have cylinder color by volume, how much the difference is. So that's the way to do it. And also you can find the percentage differences and try to compare it. So it holds true not only for the plots, you could do the same thing for table as well. So in lab 1 and lab 2, even in other labs too, you'll be making many tables and plots. So make sure you write the results, as well as don't forget to discuss. Discussion is extremely important. And as you try to discuss to the process, you must do the citation if you get information from other resources like the books, or it could be research paper or something like that. In terms of our lab report in 1-2, the way to write result in discussion is, as I said before, you have 4 steps. First step is to define any variable which you want to discuss. For instance, if you want to discuss propagation of error, then you write what propagation error is, and then write the formula for propagation of error. So maybe df by dx ux whole square plus df dy whole square. This is the formulas, and define all the symbols, what it means. And then this is important to us because you need to tell what that variable is. Without telling what that variable is, if you start with the plot, then it makes no sense. So the starting point would be always to include equation and tell what exactly that variable is. Next step is you have the data now. Express this data in the form of some kind of plot. You should have a very professional plot, or you could have in the form of table. So that's the next step. Once you have that, you write the results. What information you get from here? They write the results, and then compare that results with the other researcher and other maybe some, if you get those information from books, compare with that as well. Again, remember, you should do the citation as you write the discussion part. Okay, so these are the steps which we will follow in relation to lab 1 and lab 2, because we'll be writing result and discussion section in lab 1 and lab 2, which is a very important part of it. Conclusion is kind of summary. It's kind of summary, putting everything together. So it's kind of summary. So you try to connect together the most important results and form like a one story. And make sure you have certain objective, right? So make sure you have answer to all the objective questions. Whatever the objective you have answer to the objective questions in the summary. Okay, so you don't add any new information in the summary. It's all based on what you have in the result and discussion. So you put it together and form a story, and that's what the conclusion looks like. In relation to lab, you should address each of the presentation result questions. So in relation to our lab, so try to answer the questions that's been asked in the lab manual. I mean, it doesn't have to be always, but try to write qualitatively whatever the results you get. If sometime if it adds value, then you can write quantitatively as well, but it's better to write qualitatively the results. For instance, qualitatively means, instead of writing the volume or something, you could write like cylinder volume calculated using weight and density was greater than the cylinder volume calculated using rate. So this is more like a qualitative in nature. But sometimes if it adds value to it, writing quantitatively, then you can do that as well. And then appendix. Appendix is something in general. I'm talking about appendix. If you feel like some of the information you just want as a something to look after, but not the main part of your results, you can put in an appendix. For instance, your raw data, you could write in you could put it in appendix. Okay, because you get information from the raw data, but sometimes if somebody wants to see your raw data, then they can look at the appendix. They can also use put the calibration data here. Sometimes they use different types of chart, G table or T table. Sometimes they may want to look this one as a reference, so you can put in the appendix. So anything that you think is not very important as a main part of the report, but sometimes you can use it to just as a reference, then you can always put in the appendix. Okay, raw data and calibration data, and you can always refer to the appendix when you write your main report. So you could say the raw data is provided in the appendix A1. So you could write that way to tell like what you have in the appendix as well.